Well, hello again, Algebra 1. Today we are starting Chapter 6. Believe it or not, Chapter 6 is actually going to be the most heavily tested part on any standardized test that you're going to take. So this is a really, really important chapter. It ties in really well with what we just did. We just came out of a chapter on graphing, and guess what we're going to do today? We're going to do more graphing. So let's look at this. What you're going to do today, the goal is that you'll identify solutions to a system of linear equations by graphing. With an 80% accuracy. And as I'm saying that, you might be saying, well, what does that even mean? Well, let's see what that means. Okay, if I give you this, I bet you have an idea of what you're going to do, right? We know how to graph these. This is in standard form. If I graph this top equation, we just have to patch-eye, right? The x and y are on the same side, so it's got to be patch-eyed. So let's go ahead. I'm going to ignore my x right now on that top equation and just solve it for y. Let's find the y-intercept. So on the top equation, -3 divided by 3, it's going to be -1. So my y-intercept is -1. I'm going to put the dot down there. Now let's find the x-intercept, and let's ignore that y. So right there, it's already solved for x. It says x equals -3. That's my x-intercept. So I'm going to come back and put that there. Now, it is very, 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 very important that as we do this, that our graphs are accurate today. Okay, they have to be accurate or we're not going to get the right answers. Okay, now let's switch to the bottom one. I'm gonna switch to a blue marker so that we can see this better. Okay, so on the bottom, let's find the y-intercept first. I'm going to ignore the x and solve that for y. So I've got -3 divided by 3. That's going to be a +1. So my y-intercept is 1. And now let's find the x-intercept. Ignore that -3y. So now it's already solved for x. That x-intercept is just -3. So I'm going to put a dot at -3. And I'm going to draw my line. Okay. So now if I were to ask you what the answer was, what would you say? Or if I were to ask you to point to the answer, where would you point? I bet you can get this even before I tell you. Looking at this, it seems kind of obvious to me that the answer is right there, right where those two lines cross. And in fact, that is. Okay, let me explain to you why that is the answer and what we are actually trying to do here. Okay, the blue line is the set of ordered pairs that will be a solution to that bottom equation. The red line is the set of ordered pairs that are solutions to the top equation. And what I'm looking for is I'm looking for the one set of ordered pairs that will be a solution to both equations. All right. And so that's going to be where those two lines cross. Okay. So in this case, our solution is that dot right there. And that is the point, -3, 0. So that's our solution. If we put -3, 0 into the top equation, it's going to work. If we put -3 into the -3, 0 into the bottom equation, it's going to work. Okay, so our solution is where the two lines cross. Okay, so that's the first type of problem you're going to see today. Look at another type of problem that you're going to see today. All right, let's look at number 7. Number 7, 3x plus y equals -3. So first of all, let's find our y-intercept. So I'm going to ignore the x, and I'm going to look at my y. So right there on the top, it already says y equals -3. So that's my y-intercept. Y is equal to -3. Okay, now let's ignore the y this time, and let's solve this for x. So 3x equals -3, so I have to divide by 3. -3 divided by 3, my x-intercept is going to be -1. Again, I have to be very, very careful to make sure that my line is nice and straight. Mine got a little bit off there, and you know what? I might even go back and change that. See if I can do better. That's better. Okay. Now, Let's look at the bottom one. All right, once again, I'll ignore my x, and let's solve this for y. Okay, well, great news, it's already solved for y. Y equals 3, so I'm going to go up 3 on my y-axis. That's my y-intercept, okay? Again, we're patch-eyeing this standard form, so let's solve this for x. Well, all I have to do is divide that by 3. 3 divided by 3, my x-intercept is going to be equal to 1. Okay, so now draw this line. And where do they cross? Where are they going to intercept? They don't. Those two lines are parallel. Okay, so if we look back on number 9, we knew that the place that our answer was the place that they crossed, okay? And so for number 9, we had one answer, and it was -3, 0. That was what worked for both of those equations. When we come up here to number 7, looking at that one, it doesn't cross. So what is the answer to this one? This one is no solutions, okay? If you get two parallel lines, they're never going to cross. There is no solution. Okay, let me see if I can find one. Okay, right here. Let's do number 8. This is going to be our third and final kind that we're going to see. Okay, let's look at this top graph. Well, this top one, that's not in standard form anymore, is it? That's slope-intercept form. It's not standard form because the x and y aren't on the same side. This is slope-intercept form, so our y-intercept is going to be a +2. Okay, so let's just go up 2 on the y-axis. And then our slope is the number that's in front of the x. Well, we know the hidden number in front of the x is a 1. So that's our slope. So from our y-intercept, we're going to go up 1 and over 1, up 1, over 1, up 1, over 1, up 1, over 1. Okay? So now let's draw this line. And we want to make sure that we draw this line very straight and very clear. Okay, that's my line. Okay, and technically I should have an arrow on both ends of these. I haven't been doing that. It shows that it goes forever in both directions. Okay, now let's switch this and let's look at the bottom equation. Once again, I'll switch to some red so that we can see this easier. Well, now we're back in standard form. X and y are on the same side, so it's got to be patch-eyed. So let's find the y-intercept first. Let's ignore that x and let's solve for y. Negative y is -2, so divide by -1, and y is going to be +2. My y-intercept is +2, so I'll put the dot right there at +2. Okay, now let's find the x-intercept. So I'm going to ignore this. Well, that's already solved. My x-intercept is -2, so I'm going to come back to -2 on my x-axis, and I'm going to draw the line. Huh. That's bizarre. Okay, well, let's go back and look at what we already know, okay? Number 9, the solution was -3, because that's where they crossed, right? We're looking for the place where the two lines are crossing, where the two lines are intersecting. So number 9, the answer would be -3, 0. If we look up at number 7, we see that those two lines were parallel. They never crossed, so that was no solutions. And if we look down here at number 8, what do we see? Well, down here on number 8, we see that the two lines are actually on top of each other. It's actually the same line. So what is our answer? We're going to be infinitely many solutions. Why is that infinitely many solutions? Well, because there's an infinite number of places where those two lines are touching. They touch there and 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 there. You're getting the point, right? So everywhere along this line, everywhere, an infinite number of places it touches. Now, just one teeny tiny technical thing, okay? If you would say that it's all real numbers, that would not be correct. Okay, this time our answer has to be infinitely many solutions. There's an infinite number. We can't even count them all. They go on forever. There's an infinite number, but why is it not all real numbers? Well, real simple. This point right here, up there, negative 3, 3, that's not a part of our solution. Okay, so it can't be all real numbers. It is infinitely many solutions. Okay, so one more time, let's go back and look at these. Whenever we are solving these by graphing, we have to graph them and see where they cross. If you get one like number 9, okay, there's going to be one answer, and that's going to be negative 3, 0. The next option is like number 7, where they're parallel and there's no solutions. And the last answer is like number 8, where they are the same line and there's infinitely many solutions. So kind of side by side, here are your 3 different options, okay? There are no other options. You can never have 2 solutions with a straight line. You can never have 3. It's always going to be no solutions, 1 solution, or infinitely many solutions. All right, good luck.